I'm Zaina, and today we're making muffins. However, I have no clue how to go about it because the recipe I have only makes 6, which isn't enough in any case. So to solve this, I'm pulling out my chemistry notes over stoichiometry. This way I can make more than 6 muffins, but they'll still turn out nice and fluffy instead of burnt and flat because I didn't use enough flour or something. Stoichiometry is the study of quantitative relationships between the amount of reactants used and the products formed in a chemical reaction. It relates back to a law of conservation of mass, which says that mass cannot be created nor destroyed. That's easier to see when we're working with equations though, so we'll see this later. Chemists use stoichiometry to calculate things like how much product will be formed or how many reactants will be used to make a certain amount of product. It isn't just used in labs though. Baking is based on chemistry. To make a recipe desirable, you have to have the right blend of different ingredients. If we use too little baking soda for the muffins, for instance, they won't rise properly. In this case, our ingredients are reactants and the product is, hopefully tasty, muffins. Speaking of muffins, how many can we make? To find this, we should figure out how many times you can multiply the recipe but still have enough ingredients. The first step with any chemical equation is balancing it. This recipe provides us with an already balanced equation that produces 6 muffins. Let's start by calculating how many muffins we could make with 2 sticks of butter or 16 tablespoons. Using the given ratio in the recipe of 5.5 tablespoons for 6 muffins, we can convert this into 2 sticks for 17 half muffins total. When calculating for literal chemicals, there may be more steps in the conversion. Unlike recipes which can use tablespoons, cups, or grams without the reader having to worry about getting the right blend, chemistry tends to be more precise. Let's use this equation of iron oxide plus aluminum equals iron plus aluminum oxide for our next problems. To start, we must balance the equation. Since there are 2 Al on the right, we'll add a 2 for the coefficient of the aluminum on the left, and then same for the iron. Mole ratios are an important part of stoichiometry. The definition isn't hard to guess. It's a ratio between any 2 substances in a balanced chemical equation. For our iron oxide equation, the mole ratio between iron oxide and iron is 1 to 2. What would it be for aluminum to iron? Pause now and think about it. So for aluminum to iron, it would be a 1-to-1 ratio. Ratios aren't solely dependent on the coefficients found in equations. They must be further simplified. So 2 to 2 simplifies down to 1 to 1. Using mole ratios, we can calculate mole to mole conversions. If we had 2 moles of iron oxide, how many moles of iron would we need to have no excess reactants? So from here we can see that 2 moles of iron oxide, and we can convert that with a mole ratio of 1 mole of iron oxide with 2 moles of iron to get 4 moles of iron needed. Measuring moles for use isn't practical though. So what if we calculate the number of grams needed instead? For this, we'll reference the periodic table for molar mass. We can build on our last equation where we went from 2 iron oxide to converting it using a mole ratio of 1 to 2. And we can then take the 1 mole iron and the molar mass of iron from the periodic table, which in turn, when multiplied and divided out, will equal 223.36 grams of iron needed. Like I mentioned, measuring moles can be difficult without the right tools. Most people use a scale to calculate mass in grams. Due to this, the given measurement could be in grams. How many grams of iron would we need if we had 50 grams of iron oxide, once again, for no excess? So here we first need to calculate what the molar mass of iron oxide is, so we can get this from the iron and the oxide and multiply and add things out to get 160 grams. So from here we're going to actually start with the mass before moving on to the mole ratio. So we'll start with our 50 grams of iron oxide, convert that into moles using the molar mass, and then use the mole ratio to convert that into iron moles, into the moles of iron needed. From there, we take the mole of iron with the molar mass and get 34.9 grams of iron needed. Sometimes, however, these calculations aren't as long. For our muffins, we simply need to double everything in order to make 12 muffins from 6. So here we can take this longer equation and simply multiply it by 2. Cool, now that the recipe is doubled, let's get to baking. So far, we've learned how to calculate the amount of reactants needed to make a certain amount of product. Sometimes though, things don't go to plan. To assess this, chemists use percentage yields. A A percent yield is a ratio between the actual yield and the theoretical yield as a percentage. That just sounds like a bunch of words mixed together though, surface level, so let's break it down. The theoretical yield of a reaction is the maximum amount of product that can be produced from a given amount of reactant, which is determined mathematically using the stoichiometric calculations that we've looked at so far. For baking, it would be 12 muffins. The actual yield is, well, the amount of product actually produced when a chemical reaction is carried out in a lab. Though I planned to make 12 muffins, I lost some batter on the way and only got 11. To calculate the percentage yield of a product, you simply divide the actual yield by the theoretical yield and then multiply by 100 to get a percentage. This helps chemists assess how messy or accurate their process was. And that is the muffins. While the muffins cool down, let's recap. Stoichiometry studies the quantitative relationship between reactants and product mainly based on the law of conservation of mass. Limited reactants limit the amount of product that can be made. In contrast, excess reactants are the reactants that are partially left over at the end of said reaction. To calculate how much of the excess will be used, you use mole ratios based on the limiting reactant. Mole ratios are based on two substances in a balanced chemical equation. To convert these substances, you can use this chart. Mass, and then mole over molar mass, mole ratio over mole ratio, molar mass over mole equals mass. And simply remove the columns that you don't need. Finally, a percentage yield shows how accurate your process was through a chemical equation by dividing the actual yield by the theoretical yield and then multiplying by 100 to get a percentage. That's fun. Hope that helped you learn not only about muffins, but also stoichiometry. Have a nice day!